Right. Hello, everyone. My name is Yoni Friedman, and I'm a product manager in the AWS Artificial Intelligence Group. I'm extremely excited to be talking to you about Amazon Translate today, our brand new neural machine translation service. Over the past year, our customers have been asking us for a machine translation service. And as we dug into their needs, we found that in many cases, the fact that most of us only speak one language or two languages at best is a real barrier for business growth. Take, for example, Jin. Jin is the CEO of a company that sells children's clothes in China. They sell online only through their own website. The company has really taken off and started selling to other countries. As orders from other countries start coming in, so do customer service contacts in many languages. Spinning up an operation of multiple customer service teams that speak all these languages has been costly and time-intensive for Jin's company. Lucy's travel website has millions of customer property reviews. They know that reviews help customers make booking decisions, but more than 80% of their reviews are in English. And they find that people who don't speak English have a much lower probability of completing a reservation. They want to enable all of their customers to effortlessly read reviews. Pierre's financial services company offers their customers hundreds of thousands of news articles in many languages every day. Customers looking to invest in Brazil-based companies who do not speak Portuguese need access to news in Portuguese. Customers from France looking to invest in United States-based companies need access to news in English. They might want to see those news in French. In all of these cases, and many others, our customers need real-time translation of large volumes of content, and they need top quality. Luckily, we at Amazon have had the same problems, and we've been using machine translation to help us solve them. We translate immense volumes of content, and these volumes have only been growing exponentially sometimes over the last few years. So machine translation has really been essential to our international expansion. We use machine translation to translate product listings and descriptions, search queries, website strings and functional content, various types of communication with customer service, vendors and sellers, product documentation, and more. Over the last year, we developed our own state-of-the-art proprietary neural machine translation engines. I'll invite someone way more qualified than I am to talk about what that means in a few minutes. But the simplest way to put it is that these are engines with a revolutionary architecture that's inspired by the way that the human brain learns and processes information. We're very happy with the translation accuracy and fluency benefits that these engines brought to our own performance, and we're gradually replacing all of our engines with the neural ones. We're also convinced that they can enable AWS customers to solve problems and capitalize on untapped growth opportunities. And that is why today we're making them available as an AWS service. Let me show you an example of the difference that this technology makes. Let's look at the Wenger Swiss officer's giant knife on Amazon.de. Mind you, this knife has 87 tools and 141 functions guaranteed. It also turns out that one of these tools is a toothpick. And this is how a customer described their experience with it in German in 2015. Now, here's how one well-known open source engine would have translated this. I'm going to read it just so you guys can fully experience this. Really a very good pocket knife. Had yesterday after breakfast something poppy hang between the teeth. Because I once again found no toothpicks, I ordered mine without further ado this pocket knife. The integrated toothpick NER 3 is very stable, and very quickly I could clean my teeth. Super. To the rest, I can tell nothing, unfortunately, because I him not be emergency. So readers can get the gist of this message, but overall not that great, let's be honest. Now let's take a look at what our current neural engine would do. Really a very good pocket knife. Had a little poppy between the teeth yesterday after breakfast. Since I didn't find a toothpick again, I ordered this pocket knife shortly. The integrated toothpick number 3 is very stable, and I could clean my teeth very quickly. Great. I can't say anything about the rest because I don't need it. As you can see, we still have some work to do here with these red circles I put there. But this is much closer to the way that a human would have translated this message. The meta point I want to make here is that with these new engines, we have a good solution to many more use cases than machine translation could ever solve for in the past. Which brings me to who should use this and in what cases? And the answer is really any business that has customers who speak languages other than the ones you provide service in today, which is pretty much any business, can benefit from using Amazon Translate. Whether it is to make your existing customers, to make the experience for your existing customers more convenient, reach out to new customer bases, or even just simplify and streamline a specific part of your operation, like customer service, as I mentioned, Amazon Translate can help expand your business's reach. Now, with regard to the when, state-of-the-art machine translation is a great tool for any kind of content that flows in very large volume and is created and deprecated in a very fast pace, such as user-authored content like various chat formats, user forums, customer reviews, support forums, and the like. Situations where companies need to sift through large volumes of data to extract some sort of insight from them, such as e-discovery situations where your company might need to sift through hundreds of thousands of emails in multiple languages, and you need to really narrow that down to just a few hundred and get what you need out of those, are also a great use case for this type of tool. One thing that's important to note is that these type of use cases encompass by far the lion's share of information that organizations today have. In other use cases where information is highly sensitive and very stylistically stringent, machine translation can be used to complement human translation efforts. Rather than starting with the raw text, linguists can focus their time on post-editing machine-translated output for style and accuracy where required. As promised, at this point, I'm sure that many of you would like to learn more about how the black box work. And to tell you about that, I want to invite one of the leading scientists in the machine translation space and the head of one of our research teams, Dr. Daniel Marcu.
Thank you, Yoni, and thank you, everyone. So I have to say that building machine translation systems using data-driven techniques is not a new idea. It's been around for about 30 years. And the transition from, let's say, building systems with the help of linguists has happened in the late 80s. In this data-driven approach to machine translation, the way you build machine translation systems is by assembling vast numbers of examples of professionally translated sentences. And once you have assembled all that data, all those examples, then you let machines peek over the shoulders at those examples. And little by little, the machines figure out how to translate from one language into the other. And once you have that capability, you can take completely unseen sentences that were not part of your training corpus, so you have no previous examples of those translations, such as that shown here. And you can use the information that the machines have learned from all those examples that they have examined and turned and twisted, and then you can produce translation in another language. Now, the big fuss, or the big discovery, let's say, or the big breakthrough of the last 2 or 3 years is these deep neural architectures, and those of you who have followed the news probably recognize some of those keywords in the box. So the only significant change that has happened in the last 2 or 3 years is the type of box that does this learning, looking at all sorts of examples and then figuring out from those examples how to translate completely new sentences. Now, let me share with you just why scientists are so excited about applying this deep learning technology to the problem of machine translation. The reason people are so excited is because with neural technology, we can now solve problems that it was impossible even to imagine before. So let's consider, for example, data sparsity. Doesn't matter how much data you look at. When translating from one language into the other, you are inevitably going to run into words or lexical variants that you have not seen before. So just 10 years ago, for example, people have spent PhD theses trying to figure out how to take, for example, German compounds and split them down into smaller bits and pieces so that those German compounds can be translated properly into English. And at some point, as we were developing this technology for you, I sent an email to my colleagues. I said, OK, I think everything is going to be OK if we are never asked to translate this word. And I picked this German word from Wikipedia. It's a real word that actually Wikipedia says that is the longest ever German word published that appears in print. And the translation for that word is Association for Subordinate Officials of the Head Office Management of the Danube Steamboat Electrical Services. It's a darn long word. And I sent this email to my colleagues, and the answer came back and said, no, Daniel, actually, we're not doing that bad. So our translation system produces for this very complicated word the translation Danube Steam Navigational Power Plant Subcontractor, which, as you can see, it's pretty close to the meaning of the reference translation. And all this kind of happens automatically, magically, without we having to invent new technology and essentially trying to figure out how to split that long compound into smaller bits and pieces. In traditional statistical machine translation technology, it was extremely difficult to model broader or larger contexts. So let's look at this example. The submarine had an electrical issue, and it could not be fixed. Now, when you translate that into another language that is very rich morphologically, that has gender, depending on whether you talk about submarine or car or something else, depending on whether that object is masculine or feminine in the language that you're translating, that it has to be translated differently. And statistical translation systems, they have a very narrow focus. They just look a little bit to the left and to the right of what they're translating at that moment, and they very quickly forget the context of the rest of the sentence. Now, with neural technology, you can deal with such phenomena in a much easier way. And you've seen in the examples shown by Yoni about that pocket knife, how much of a difference the ability to consider larger contexts makes for the quality of machine translation system. Another reason we, as scientists, get excited about this technology is because it enables us to build machine translation systems even in instances where not too much parallel data exists. Languages for which, let's say, if you take French, and if you go and visit the web, there's tons and tons of content, billions and billions of words that have been translated in the past by French and English people and that are publicly available. But if you take a language such as Uzbek, much less data. And for many years, scientists have hypothesized that maybe there is a way to take, let's say, knowledge about Urdu that has a little bit more data than Uzbek, and because Urdu is very much related to Uzbek, maybe you can use that to build a better Uzbek to English machine translation system, although, let's say, you have very little data for that language. And that was a hypothesis that has been around the science world for years, for 10, 15 years, but nobody really was able to make a difference. And now, again, with this technology, kind of out of the box, we can exploit data that is available in related languages. Even more, we can take even unrelated languages, such as French, and we can bring that data to bear and improve the performance of what is called these low-density languages, which is just fascinating. I remember, let's say, even 3 years ago or 4 years ago, I could get together with my friends in image recognition, who are doing research in image recognition, and we can have a nice chat over a beer, but I could not understand what they were talking about. The papers that they were writing at that time, they were completely opaque to me. I could not understand that science field at all. And they did not understand what we people in natural language processing and machine translation were doing. Now, turns out that all of us have transitioned to using these deep neural technologies, and we can talk much more than just having fun and having beer. We can borrow techniques that are developed, let's say, for image processing and use them for natural language processing, vice versa. We can learn from each other. We can understand each other's papers. And that also has tremendous implications because not only we understand each other and progress happens much faster because of that, but also we can put together these systems in ways that it was impossible to do before because they essentially use the same underlying technology. I think probably the reason this technology makes it most rewarding for scientists, let's say up to 2013, 2014, the way people in natural language processing developed the engines, even in the statistical frameworks, was something like this. So you would go to the office, and then you would do some sort of error analysis, and you would say, okay, I see all these problems with my outputs. How can I fix them? And then you would try to hypothesize some reason for the system producing those bad outputs. And you would try to hypothesize what kind of signal is in the input that maybe somehow I can learn, I can make visible now to my machine translation system, let's say, and maybe by exploiting that additional signal, the machine translation system is going to make fewer errors. And then you would spend tremendous amounts of time writing code to learn that new signal, tremendous amounts of time to make sure that that signal is adequately incorporated into the algorithms used by the statistical machine translation systems. And after a month and month, you would hope, okay, now I'm doing well. So you spend lots of time trying to figure out essentially what features help. Now, with the advent of the deep neural technologies, scientists no longer do that. So the representations that are good for improving machine translation performance are automatically learned by the systems. So sometimes you read in the news that, oh my God, let's say some of the jobs are going to go away. Drivers will no longer need in the United States because machines are going to drive our cars. I think as technology evolves, it's not that machines are replacing humans. It's just that the nature of the jobs changes a lot. And the same thing in science. So if you don't adapt and if you don't change what you're doing, I think it's very difficult to stay relevant over a long period of time. So these are all reasons that make scientists excited, right? But from your perspective, you have other reasons to be to be happy with this adoption of the newer technology. And I think probably the biggest reason is that with these neural systems, the progress of improving machine translation technology has just completely changed. So just to put things in perspective, in the past, as we build these statistical systems, let's say, for the last 10 or 15 years, on one particular metric that is used by the community that is called the Blue score. The community was extremely happy to publish results where improvements were of the order of 0.5 or 1 blue point. Doesn't matter what that means, but just to give you the order of magnitude. So, and in general, let's say year over year, the technology or the systems that you had access to improved at the rate of about 1 blue point per year. Since only 2015, you could see how, let's say just for English-German, these are results published by the whole community of scientists around the planet, the best results published just in the last 2 years, how on some publicly available data set where scientists go and they compare their studies, how this neural technology has improved by more than 12 blue points in 2 years or so. And in the other color, in the pink color, what you see there is the performance of the best statistical machine translation system that was trained on the same amount of data. So you see that just in the last 2.5 years, essentially the neural technology has left the statistical technology in the dust and has improved at a tremendously rapid pace. And because of that, you can today have access to much higher quality machine translation engines. As Yoni mentioned, we also use these engines quite a lot internally. And in our own internal use cases, we have been measuring double-digit improvements in translation accuracy and fluency across many, many language pairs. So what should you expect from this field moving forward? In spite of the enthusiasm that you see now, not only in our own teams and in our own groups, but I think across the board, we don't think that we are done. So just want to set the expectations correctly. So from time to time, these machine translation systems still produce results that do not match human translation quality. So we still have ways to go until we can replace, let's say, in all instances, human translators. So you need to be careful about the use case that you're going to use these systems for. So, but I'm convinced it's going to happen. So just think of, let's say, OCR technology. 30 or 40 years ago, it was unimaginable that you could scan some text, and then you can have a representation of that text, even handwritten, done with 100% accuracy or with 99.9% accuracy. And that is now part of every single printer. It's part of every single device that we have. We just expect that to happen somehow, and it happens. And I think all these natural language technologies are evolving in some sense to get to the same point. The other thing that you should expect from us also is making this service available on increasingly larger number of languages. So obviously, that's super important. So we want to make sure that whatever language needs you have, we can meet those needs. Also, we expect to spend significant amount of effort. As I mentioned now, all these additional technologies that we talked about during the address even this morning use the same kind of deep learning technology. So now it becomes much easier to bring together these technologies in ways that it was not possible before. For example, take a speech recognition system and integrate it with a machine translation systems in ways that it was very difficult to do in the past, and create new user experiences that significantly improve on user experiences that we had in the past. So with that, I would like to let Yoni talk about some sample applications.
Thank you, Daniel. People still hear me? Okay, great. Had a little bit of an accident there. So we talked about some of the problems that we want to solve, what we're doing with this at Amazon. And Daniel walked us through how the systems work under the hood. Next, we wanted to take a look at a few examples that integrate Amazon Translate into actual pipelines. So a lot of people internally have gotten very excited about this new service and built some really cool demos for us that address some of the problems that we mentioned before. First, let's take a look at an example of live chat translation. Remember Jin, who needed the solution for enabling multilingual customer service? So this is a similar use case that we modeled here. In this implementation, Kashif, a solution architect in AWS, who works with Twitch, built an app that translates Twitch channel chat so that users can see what other participants are saying in their own preferred language and participate in the conversation even if they don't speak the language of that specific Twitch channel. Let's take a look.
Hi, my name is Kashif Imran, and I'm a Senior Solutions Architect at AWS. This is a brief walkthrough of the app showing real-time translation of Twitch chat. Here you see I'm on a Twitch channel where a streamer is playing game and live streaming it on the channel. You also see live chat on the right side of the screen. This is a German channel, so most of the communication happening here on the channel is obviously in German. I don't speak German, but this channel sounds interesting, and I'm curious to know about the conversation happening on this channel. Let's see how we can get this real-time chat translated and understand the conversation happening on this channel. Let me copy the name of the channel and switch to the app. I'll paste the name of the channel, select the source language, in this case we'll choose German, select the target language, which in this case I'll choose English, and click Go.
Connect to channel _Sam. You should now be getting live chat messages.
And voila, we are connected to the channel. We're getting the real-time messages on the left side of the screen, and the translation of those messages are on the right side of the screen. Let me go ahead and introduce myself to the channel. So if I type a message and hit send, you can see even though I typed the messages in English, it got translated in German. And if we switch back to the channel, you can see it's also posted in the channel in German. Now let's look at another channel with Twitch app and our translation app side by side. You see as messages are coming in the chat, they are instantly being translated and displayed in our translation app on the right side of the screen. Now let's talk briefly about how the application is built. Here you can see the architecture of our app is quite simple. Our app uses a Node.js library to connect to Twitch chat and start receiving real-time messages. As those messages come in, we use AWS SDK to call Amazon Translate, get the translated messages back, and display them in the UI. If user enable the voice option, we then use AWS SDK to call Amazon Polly and get the synthesized speech back for those messages and then play them back to the user. Let's now dig a little bit deeper and look at the code to see how the application is built. Looking at the code, the app has two files, index.html and app.js. Index.html has all the necessary UI elements to get user input and show messages. App.js has less than 100 lines of code to get real-time messages from Twitch chat, get those messages translated, and then display on the UI. As you can see, we'll begin with some initialization code to wire up the UI. Then we have onChat function, which gets called when the messages arrive. We then call Amazon Translate to get those messages translated and display in the UI. As you can see, more than half of the code here is to wire up UI elements and getting and setting values for those elements. Whereas the code to translate the messages are only a few lines of code. In this case, I used Twitch chat as one of the source for real-time message translations using Amazon Translate. It can easily be applied to many other real-time streaming text scenarios like other chat platforms, customer service interactions, message boards, and more.
All right. Making chat accessible to anyone is an extremely powerful adoption, acquisition, and retention tool for companies. And as you can see, it's very easy to achieve that with Amazon Translate. In the next example, we modeled Lucy's use case, another popular use case where on-demand user-authored website content is translated. This demo was built by two solution architects from the exotic country of Italy. And of course, they picked beautiful and fast cars to play around with. Diego and Giuseppe built a mock vintage vehicles e-commerce website that allows users to browse and simulate buying vintage vehicles. Let's take a look.
Hi everyone. Today I'm going to show you how you can leverage Amazon Translate's ability to provide high-quality on-demand translations. As you can see, the Vintage Vehicles is a mock e-commerce website where you can buy and review vehicles. After selecting a car, you can see that a review is already there. By clicking on Translate, we request the translation of the review into one of the available 6 languages. In order to add a review, we have to log in with an Amazon account. Once back to the page, we are going to write a review in Spanish. I'm just typing the review. As you can see, the review has been added successfully. We will try to translate it back to English and we get the result within a few milliseconds.
From the architecture perspective, the e-commerce website is a JavaScript single-page application hosted on a public S3 bucket and delivered through Amazon CloudFront. Users can authenticate with their Amazon credentials using Amazon Cognito user pools for user authorization. The web page makes REST API calls to Amazon API Gateway, which invokes Lambda functions. Then, Lambda functions interact with Amazon Translate to execute translations, Amazon Aurora as the main database of the application, Amazon Comprehend to analyze the sentiment of reviews, Amazon DynamoDB to store translated reviews, and Amazon Kinesis Firehost to log translations. Now, let's take a look at the code and the API Gateway configuration. As you can see, the get method of the review resource is used to get a translated review by invoking the getReview Lambda function. If we look at the Lambda Python code, you can realize that asking Amazon Translate to translate some text is a matter of writing only one line of code.
So again, we see that customers can solve these types of problems that in many cases were not solvable in the past as easy as writing a few lines of code. And this is incredible to me. For this next one, I'm going to call on the gods of demo and actually attempt to do something in real time. So we'll see if this works. This is an example of a translation chatbot built by Steve, a solution architect from the UK. Let's take a look. So this is a web app that Steve built, which is, like I said, a translation chatbot. What I'm going to do first is I'm going to ask it to translate. You know what? Let me do a typo. And let's do from English to Spanish. Okay, good. I recognize that I wanted to translate stuff. I can't think of anything inspirational, so let me type in something aspirational. And voila, Translation seems good. I don't speak Spanish. Please let me know if you do. So just for those of us who don't speak Spanish, I'll go ahead and copy a quote about translation from this website. And please notice this translation that they have here to English. So they say, life belongs to the living, and those who live must be prepared to change. It's sort of related to translation, I guess. Oh, wait. First, let's tell it that we're translating to German now. Translate from German to English. All right, let's paste that in. See what that gives us. Life belongs to the living, and who lives must be prepared for change. So pretty close. Pretty good translation. Let's now talk about the architecture briefly. So in this case, Steve used Amazon CloudFront to provide the CDN, and he hosted the web app on Amazon S3. Amazon Cognito is used to identify pool is used to pass temporary AWS credentials to the app. Amazon Lex, which basically powers this whole interaction, interacts with user requests and for translations. And AWS Lambda retrieves cache translation and requests new translation from Amazon Translate. Amazon Translate is obviously used to provide the translations. And finally, Amazon Poly can be used to synthesize the speech back to the user. And by the way, guys, all of these code samples are going to be available in our documentation to get you started if you want to build something similar. Next, another example of what the service can do. And now we actually have the pleasure of hearing about it directly from a customer that was part of our closed beta. Joining us all the way from Australia, Andrea Walsh is the CIO of Isentia. Thank you.
Excuse me, sorry, I've got a tickle in my throat from the plane journey yesterday. So thank you very much. I'm delighted to be here to share our story of working with the team on Amazon Translate. So first of all, I'll start with an overview of Isentia and our core product offering, just to give you some context of who we are and what we do. So Isentia is a media intelligence company. This means that we deliver real-time, relevant media information to our corporate communication clients. We have 5,000 clients in the region and 84 of the top 100 brands. So if you work for a global organization and they have an Asia-Pacific presence, then you're likely to potentially be using Isentia services today. We operate in 12 countries, and our focus is on the Asia-Pacific region, where we are the market leader. Our core product offering is called Media Portal, and this is a cloud-based web and mobile application. It's often described as the Bloomberg for corporate communications. So it's the go-to place if you're in corporate comms and you work in a corporation, a government agency, or industry body, who each day need to understand how they're being represented in the media. So let's now talk about Media Portal Stories. And this is a new feature that we built this year inside Media Portal. A challenge for the corporate communications team is that with the growth of social and online, they're dealing with a huge amount of data, and it's transformed the media landscape. So our clients now have to be across this large volume, and it's produced across many platforms. The media cycle has now gone to a 24/7 cycle, and a huge increase in the number of influencers. Gone are the days when it's just the journo who writes the press release or the TV interviewer. And so what Stories does is it brings all this information together to have one place, to have an integrated view. It tracks stories as they're unfolding. It identifies trending topics, the influencers, and the velocity. It's built on Isentia's natural language service, which is hosted with AWS, and it streams real-time data. The service continuously identifies entities and applies algorithms to classify which of these entities are important and related to each other in order to form a story in real time. So we ingest and process content today in 10 different languages in Asia Pacific. An average day, we can be processing 9 million items. But for our clients, that data volume is growing all the time. And the velocity also varies in real time. What we can see on the screen is a typical day for us across the different media types. So you can see TV, online, press, etc. However, we don't always know when a story that is relevant to our clients will break and go viral, causing a significant spike in content. So some of you may remember there was an incident about 3 years ago with Beyonce and her sister, Solange. It involved somebody slapping somebody, apparently. Well, Solange was due to tour in our region with one of our clients. That client, as a result of the incident, has a 1,700% increase in Twitter content alone. That client had to try and monitor that brand with that spike of content. So it highlights how much more complex the landscape is becoming with the growth of social and online platforms. It makes it both exciting and very challenging for us at Isentia, but also our clients. So just for some history on our cloud journey, so we started our journey just over 2 years ago. And you'll see from that last slide, the volume and complexity in our region is growing. So in addition to not only moving existing products to the cloud, we also needed to build, and we did build, a new data intelligence service that helped us manage the unpredictable content spikes that we were receiving. But importantly, we also needed to be able to use technology to more effectively provide services to our clients, such as translations. So let's share our experience with translations, and I'll stay focused on Media Portal and stories. So let me share some of our challenges at Isentia. We've addressed translations in the past by using people. However, it's not scalable, it's slow, it's certainly not cost-effective, and it also doesn't meet the growing demand for real-time accurate translations. We need to support Media Portal stories by identifying patterns across multiple languages to enable clients to make timely decisions. So for example, a client in mainland China may be receiving content in English, Mandarin, and Bahasa, which they need delivered to them in their first language. And across the Asia-Pacific region, our clients require thousands of translations a day. Speed and quality is absolutely critical for our clients in order to make these timely decisions. So the first opportunity we identified with the team was to integrate Amazon Translate with Media Portal. And our objective was to provide clients with the ability to translate content on our market-leading platform. So for Isentia clients, it's also important that we're able to offer a choice between human and automated translations. Some clients, such as government agencies, require us to provide them with 100% full transcription that is being validated by a person. So you'll see here again on the screen, to support this choice, we offer automated translation using Amazon Translate and professional translation via Isentia. On the left of the screen is a coverage card from inside Media Portal, which shows the news headline, a summary of the news article, and some metadata for an English news item that's relevant to our client. The team at Isentia made a simple API call to translate the text in real time using Amazon Translate. The team were also able to translate single text as well as whole paragraphs at a time. The results are on the right of the screen, which highlights how simple it was for the team to do. The second opportunity was to support Media Portal stories, to combine those diverse media items in different languages that we talked about. So we turn now to the integration into our pipeline. Initially, our stories algorithms were single language based. However, our clients need to know how these stories that are relevant to them are evolving across multiple languages and multiple platforms. So the client in China who's receiving the data across those platforms and those 3 different languages, we're seeing 3 different stories. And what they need is a single story regardless of that language. So we have here a very, very simplistic view of our data pipeline, but it illustrates how we're able to use Storm to integrate Amazon Translate within our existing services for real-time results. We didn't need to re-engineer our pipeline, which was absolutely critical to us. Again, I can't emphasize enough how very easy and simple this solution was for us. So by integrating the pipeline, we can support Media Portal stories. So what we see on the screen are the results of that translation in the pipeline. This enables us to translate data to support multilingual algorithms. The process is to call Amazon Translate, translate the entities that we've identified, then create stories based upon matched entities across the multiple platforms and languages. On the screen are 2 examples of media items in different languages, and they've come together to form a single story. So at the top, you can see a news item in English from the Australian Financial Review, and on the bottom, we have a news item from a Chinese news site. Both have been included in the story due to the translated entities, and again, this was done in real time. So the outcomes. Well, Amazon Translate showed us that we can reduce the dependencies on human translation. It's proved to be very cost-effective and very important for us. Its flexible translation model enables us to keep people in the process where we need to. It significantly reduced the turnaround times and also allows us to apply data mining algorithms across multiple languages to support Media Portal stories. So in summary, why Amazon Translate? Well, we've trialed other solutions, and Amazon Translate met our quality requirements. It complements our event-driven AWS serverless architecture, our current AWS footprint and security model. It translates whole paragraphs in sub-second timeframes, which means on-demand translations is a reality for us at Isentia. And most importantly, it's also scalable. So looking back at those volume spikes, this was not a concern for us. So for Isentia, this was a very successful test, and we really look forward to continuing to work with the AWS team. And thank you all again for your time today, and I'll pass you back to Yoni. Thank you. Thank you.
Thanks again, Andrea. Really, the best part of building these services is seeing how customers actually use them, and this is just bliss for me to be looking at what you guys built. Lastly, let's talk about what we currently are offering for the preview, the limited preview stage. So we're offering 12 language pairs to translate between. You can translate from English to Arabic, simplified Chinese, Spanish, Portuguese, French, and German. It takes in plain text as input and is able to generate translations of about 30 words in usually less than 500 milliseconds. That's latency for the service. When the language, when the source language is not passed with the translation request, you can use Amazon Comprehend to identify the language together in that same workflow. Getting started with Amazon Translate is easy. I think we've really passed that message along. You can call it through the AWS CLI or multiple SDKs in whatever your language of preference is. These 3 commands that we're showing here is all you need to get a translation back. In terms of pricing, so the service is absolutely free to use during preview. All we ask in return is your candid feedback. Give it to us early, give it to us often. We're really looking forward to it and want to learn from it to build a better service for you. Once we're generally available, we will charge $15 per 1 million characters, and we will also offer a 2 million characters monthly free tier for the first 12 months of using the service. We will obviously not count the preview period as part of those 12 months. Just to give you a bit of context of what that 1 million characters mean, you're talking about 2 novels or so, 200,000 words, about 2 novels, or 400 news stories. So you can translate 400 news stories to a different language for $15. If you translate immense amounts of content, you can reach out to us and we can talk about adjusted pricing as well. You can use Amazon Translate to translate anything from publicly available chatter to your company's most sensitive documents, because your data is protected by AWS security standards. You can use SSL certificates to encrypt the data that passes from you to our service. And you can use AWS Identity and Access Management, known as IAM, to securely control access to your resources. Rest assured that your data is securely stored at rest. This is day 1 for us. We're extremely excited to be offering this service, and we really look forward to seeing the great things that you will build with it. Please go to this address to request access to the preview. We look forward to the applications and feedback. And before I let you go, I must prove to my wife that I was actually working here. So I'm going to take a quick selfie, if you don't mind. Thank you very much.